Hi everyone, this is Jagjit. In this question, they've given us that 0.0021 grams of MgCO3 will dissolve in 1 liter. Okay, that means we can dissolve these many grams in 1 liter, and the question is asking us to express the solubility in grams per 100 ml. In other words, they're asking us how many grams are going to dissolve in 100 ml. So let's say we have 0.0021 grams of MgCO3, and that can dissolve in 1 liter. And guys, how much is 1 liter in ml? That's 1000 ml. So we know these many grams can dissolve in 1000 ml, and we want to know how many of those will dissolve in 100 ml. So we're just going to times by 100 ml. ml is going to cancel, and you're going to get your answer. You're going to punch this in your calculator, times it by 100 divided by 1000, and your answer should be 2.1 times 10 to the power minus 4 grams per 100 ml. So we can dissolve 2.1 times 10 to the power minus 4 grams in 100 ml. In other words, that's your solubility in grams per 100 ml. Okay? And the next question. So the question says you have a solution of FeBr3. You have a solution of FeBr3 where concentration of Br minus is equal to 0.36 molar. And the question is asking us to find the concentration of Fe3 plus. Okay? So you have a solution of FeBr3. So guys, the first thing, okay, 99% of the times in this chapter, the very first thing we need to do is we need to write the dissociation equation. Okay? So we have FeBr3, and we're going to break this up into its ions, okay? When you break this up, straight away you know what's the charge of Fe going to be. Well, you see, they crisscross. That means the charge of Fe should be 3 plus. So this must be Fe3 plus aqueous. The charge of Br would be this, which you don't see anything. That means it's 1. So Br is going to be just minus 1. Now anytime you write this equation, make sure you balance this. I have one Fe, one Fe3 plus, so we're good for that. For Br, I have 3 of them, but over there I only see 1, so we need to put 3 over there. Now we do know that the concentration of Br minus is 0.36. Now guys, let's look at the number in front of Br minus, that's 3. What's the number in front of Fe3 plus? That's 1. That means the concentration of Fe3 plus should be this number divided by 3. So Fe3 plus is just going to be 0.36 divided by 3, which is 0.12 molar. So our concentration of Fe3 plus is just 0.12 molar. It's going to be 1/3 of that. Okay? We'll do a couple more examples. Question says we can dissolve 3.20 times 10 to the power minus 2 moles of FeNO3 in 2 liters. So the question says we can dissolve 3.2 times 10 to the power minus 2 moles of FeNO3 in 2 liters. And the question is asking us to find the concentration of Fe3 plus and NO3 minus. So as a first step, what we need to do is we need to find the concentration of FeNO3. Okay? And how do we get the concentration? We take our moles and we divide it by the volume. Okay? We take our moles divided by the liter. Because molarity, big M, this capital M, is just moles per liter. So we're going to take our moles and divide it by the liter. We have 3.20 times 10 to the power minus 2 moles of FeNO3. And we're going to divide it with 2 liters. And this tells me that I have 1.60 times 10 to the power minus 2 moles of FeNO3 per liter. Now, moles per liter can be just written as molarity, which is your concentration. Now, this is just concentration of FeNO3. Okay, so we just found the concentration of FeNO3. In the next step, we're going to take FeNO3 and we're going to break it up into its ions, okay? So what's this made up of? It's made up of Fe3 plus, which is aqueous, and NO3 minus. But we just need to make sure the equation is balanced, okay? I have one Fe, so we're good for that. For NO3, I have 3 of them, so we need to put 3 in front. Concentration of FeNO3 was 1.60 times 10 to the power minus 2. Now the molar ratio is 1 to 1 for this. That means the concentration of Fe3 plus will be the same. So Fe3 plus is just going to be 1.6 times 10 to the power minus 2. But NO3 minus has a 3 in front, and this one just had 1 in front. That means the concentration of NO3 minus is going to be 3 times that much. So it's going to be 3 times 1.6 times 10 to the power minus 2. Okay, which is just going to be 4.8 times 10 raised to the power minus 2. So we can say our concentration of Fe3 plus is just 1.60 times 10 to the power minus 2 molar, and my concentration of NO3 minus is 4.8 times 10 to the power minus 2 molar. Okay? So that's our final answer, folks. So in the next example, they're telling us that we have 30 ml of 0.85 molar BaNO3 and I added 50 ml water to that. So I had 30 ml of 0.85 molar BaNO3 and I mixed 50 ml water. I added 50 ml water, and the concentration is, and the question is asking me to find all the concentration of the ions. So guys, what happens anytime we add water? The concentration is going to change. Okay, it's going to get more diluted, so the concentration is going to change. And anytime we're trying to find the new concentration due to addition of water, we use our chemistry 11 formula, folks. M1V1 is equal to M2V2, where this is initial concentration times initial volume is equal to your final concentration times final volume. Now guys, what was my initial concentration? That was 0.85, and my initial volume was just 30 ml. We can leave these in ml, guys. As long as both of these volumes are in ml, they're just going to cancel out, so we can use ml in this formula. For M2, that's my final concentration. That's what we're trying to find. Our V2 is the final volume. Now guys, I had 30 ml and I added 50 ml on it. So what's my final volume going to be? 30 plus 50, which is 80. You're going to divide both sides by 80. You're going to punch it in your calculator. And if you've done that correctly, this should give you 0.31875 molar. So guys, that's your concentration of BaNO3 2. And if I want to find concentration of each ion, you're going to take your BaNO3 2 and we're going to split this up into its ions. So that's going to give me Ba2 plus and NO3 minus. But we just need to make sure we balance these properly. I have Ba2 plus, just Ba2 plus, so we're good for that. For NO3, I have two of them, so we need to put two over there. Now the concentration of BaNO3 2 was 0.31875. So this was 0.31875 molar. Our molar ratio is 1 to 1 for that, so Ba2 plus will be the same as that. So Ba2 plus will be 0.31875 molar. And our NO3 minus has a 2 in front. Now this only had 1, so this one's just going to be twice of that, okay? So you're going to take that and multiply it by 2, and you should get 0.638 molar. So we can say our concentration of Ba2 plus is just this number, which is 0.31875. And my concentration of NO3 minus is just going to be that number, which is 0.638 molar, okay? And that's how you're going to do these dilution questions, okay? Now next up is going to be a more challenging dilution question, okay? I want you guys paying attention. So in this question, we have 67 ml of 0.25 molar BaCl2. It's mixed with 25 ml of 0.3 molar NaCl. Now guys, this one's a more challenging question than the previous one. In the previous question, we just added water. In this question, we're adding a different volume. We're adding a volume, but it's not water. We're adding another compound, okay? So clearly, the volume is going to change, which means the concentration is going to change. But there's going to be a change in concentration in this and change in concentration in this, okay? In this question, they're asking us to find concentration of all the possible ions. So this is how we're going to approach this, folks. We're going to first solve for BaCl2. And then we're going to solve for NaCl. Okay? For BaCl2, we know there's going to be a change in volume, so there's going to be a change in concentration in this one. And we're going to find a new concentration by using the same formula. M1V1 is equal to M2V2. Now, what was my initial concentration of BaCl2? That was 0.25. And my initial volume was 67. Final concentration is what I'm trying to find. And my final volume is going to be 67 plus 25. You added 25 ml to 67. And that's going to give you 92. We're going to divide both sides by 92. You're going to punch it in your calculator. And if you've done that correctly, your answer should be 0.182 molar. And that's my final concentration of BaCl2. Now you're going to take your BaCl2 and break it up into its ions. You're going to get Ba2 plus, aqueous, and Cl minus, aqueous. We just need to make sure it's balanced, okay? We have one Ba2 plus, one Ba2 plus, so we're good for that. For Cl, I have two of them, so we need to put two over there. So if this was 0.182 molar, that was my concentration of BaCl2. This is going to be same as that because it's 1 to 1. So it will just be 0.182 molar. And this one's going to be twice of that, okay? So it's going to be 0.364 molar. So we found the individual concentrations for BaCl2, and now we're going to do the same to NaCl. Again, guys, we had 25 ml of 0.3 molar NaCl, but then you added a new volume, so there's going to be change in concentration. And we're going to find the new concentration by doing M1 V1 is equal to M2 V2. Now, what was my initial concentration of NaCl? That was 0.3. Initial volume was 25. Final concentration is what I'm trying to find, and my final volume is going to be 67 plus 25, which is 92. You're going to divide both sides by 92. And if you punch it in properly, your final answer should be 0.08. 0.08, roughly 2 molar. And that's your final concentration of NaCl. Now we're going to take our NaCl and break it up into its ions. It's going to give me Na plus aqueous plus Cl minus aqueous. Now what was my concentration for NaCl, folks? It was 0.082 molar. Now these are all 1-to-1, so both of these concentrations are going to be the same. Okay, so these are just going to be exactly the same, 0.082, 0.082. Now guys, the question was asking us to find the concentration of each ion, okay? So our first ion is Ba2+. We're going to write our concentration for Ba2+. Well, Ba2+ shows up only on this side. So my concentration is just going to be that number right there, which is 0.182 molar. For Cl minus, now guys, this one's tricky. Your Cl minus shows up over there and it shows up over there. So our final concentration of Cl minus is going to be this number plus that number. So that's just going to be 0.364 plus 0.082. Okay? Roughly it's going to be 0.45. Then we have Na plus. Again, Na plus just shows up on that side. So it's just going to be 0.082. So that's how you're going to get the final concentration of each ions. Guys, I want you to be very careful. Whenever you have two different compounds that are being added with different volume, I want you to solve for these separately, okay? And then if any ion shows up on both sides, you just add up their concentration and you're going to get your new concentration. Thank you very much, folks.